Welcome or welcome back. I just wanted to jump on to give a quick disclaimer before this video that it's only focusing on the basic rules and properties of derivatives. I'm not covering chain rule in this video. That'll be in the next one. So please subscribe so you can make sure to not miss that. In this one, we'll just be going over quotient rule, product rule, exponential and logarithmic derivatives, trig derivatives, power rule, all that, but no chain rule. That'll be in the next one. If this video helps you out, please be sure to give it a thumbs up and let's get started.
All right, starting out with the limit definition of a derivative, here is the formula. We're going to use that formula here for this problem. I like to start just by getting f of x plus h out of the way. So I'm going to go ahead and find f of x plus h for this problem. So we're just plugging in x plus h in for x. So on top there, I have x plus h plus 8. And then on the bottom, I got 3 times the quantity x plus h minus 5. So now we're going to go ahead and clean that up by distributing the 3 to the x plus h on the bottom. Top stays the same. So I got a 3x plus 3h minus 5 there on the bottom. Now I always start by rewriting the formula. The more you rewrite the formula, the easier it'll be to memorize in the long run. So I just start by writing f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And that's coming directly from our formula. Now we're just going to plug and chug. So I got f of x right there, which comes from the problem. And then we're also going to sub in f of x plus h, which we found previously. All right, so just subbing everything in here. We're first going to rewrite the limit because we haven't taken a limit yet. It's honestly going to be a while until we do. And then I'm going to plug in that f of x plus h that we found at the beginning. And then we will go ahead and subtract f of x, which was given in the problem. Now that we have everything written out, here comes the tricky part. So in order to clear that fraction on top, I kind of got like a double fraction situation. What I'm going to do is multiply by the least common denominator. So in this instance, the least common denominator is unfortunately both of those terms there on the bottom. They have nothing in common, so we're just going to multiply by both of them in order to clear that fraction on the top. So I have to distribute both of those terms to each piece there in our limit on top. After distributing that to both of those pieces, you'll see that the bottom, the denominator of that fraction on top there will cancel, which is what we wanted to happen. So I'm left with that x plus h plus 8 on the top from what we had previously, but then I also have the 3x minus 5 from the least common denominator that we'd multiplied by. And then the second piece, I have the x plus 8 from before, as well as that 3x plus 3h minus 5 that we multiplied in. So here on the bottom, just leave it the same. Do not try to simplify this, FOIL it out, do anything fancy. It's just a waste of time. So we really want to leave it how it is on the bottom. Take my word for it. So I do unfortunately have to clean it up on the top. So I'm going to go ahead and multiply everything together. It's a pain, I know. I did not enjoy it, but we got to do it. So you're going to go ahead and multiply all the terms for that first piece as well as all the terms for that second piece. I have to be really careful with my parentheses here because that second piece of what was f of x is being subtracted, right? So that's coming from our formula that we're subtracting f of x. So I need to make sure that that negative sign gets distributed to each and every piece because that entire chunk there is all being subtracted. So I'm going to go ahead for the sake of time and all of our sanity and just combine all these terms together while also distributing that negative at the same time. So then we can see how a lot of this ends up canceling out. So hopefully it makes sense there how all of those pieces end up canceling out because we have one that's positive and one that's negative. And then all that we end up being left with after we simplify everything is a minus 5h minus 24h on top. And on the bottom, once again, we're leaving it exactly the same. We're going to go ahead in the next step and just combine the two like terms on the top. Since they're both in h, we can combine them into a negative 29h there. And again, the bottom staying the same. So we'll cancel out the h's. This is why we don't want to multiply it out there, because if you do it right, that h on the bottom should always cancel out. Okay, so just jumping out here for a little more space. Sorry to zoom in and zoom out so much. I'm just rewriting everything now that that H is gone. So rewriting all the terms, and then we're going to go ahead and take that limit there. So I'm taking a limit as H approaches 0. So that second term down at the bottom where I have a 3H, that will actually go to 0 because 3 times 0 is just 0. So now I've officially taken that limit. And this will leave us with our final answer now, which is the derivative of that original function, negative 29 over 3x minus 5 squared, just combining those two. And that's my final answer. So using that limit definition is obviously super painful. So luckily we have a couple rules and properties we can use in place of it to make things go a lot smoother. So these are just a few of the rules and properties we discussed in the last video. So if you missed that, definitely go check it out. This first one here is going to be using product rule. So we will take that power and drop it down. So x cubed, I drop down the 3, 4 times 3, and then you subtract 1 from the power. So I got 3 minus 1, which is 2. And then we're going to do the same thing with each piece. The derivative of a constant, that negative 1 at the end just becomes 0. So here we can see that was pretty quick, pretty simple. It's nice taking a derivative of a polynomial now that we have those rules. So this next one here is going to involve product rule. So we actually have two functions multiplied together, right? So I'm going to use product rule for that. For product rule, I do the first one. So I just rewrite that first function times the derivative of the second function. So derivative of tan x is secant squared x plus the second function. I just rewrite it tan x times the derivative of the first function, which is 2x from that power rule. So here I'm just rewriting the product rule, which is just the first function times the derivative of the second function plus the second function times the derivative of the first. Again, if you do it in a different order, no big deal. Multiplication and addition are commutative, so this one, the order doesn't matter. Now, in the next step, I'm just going to clean it up a little. I did kind of want to factor out a secant, but I didn't, so you're welcome. So this next problem here will be using quotient rule. So we have two functions that are being divided. So then we're going to use quotient rule. For quotient rule, I do bottom, which is just the bottom rewritten, times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So we'll go ahead and write out quotient rule off to the side again, just for you to see that. So again, I do bottom d top minus top d bottom all over the bottom squared. Some students do low d high minus high d low. Either way, totally fine. This one, the order does matter. So since we're subtracting, the order of those two on top does matter. So you want to make sure that you're using the correct order with quotient rule. Now we're just going to clean everything up, and we'll get our final answer there. So much easier with quotient rule to do this than it was previously doing the limit definition. So now we have another product rule, example of product rule. So two functions multiplied together, derivative of e to the x, it's just e to the x. That's actually my favorite derivative. So that's being used here. I'm not going to write out product rule again since it's up above and we've talked about it a bunch of times, but this is just another example. And here I can actually factor out a 7 and an e to the x to clean everything up a little bit. So this is just one last example using quotient rule, but here we have a natural log function as well as a trig function. So I'm doing, once again, bottom times the derivative of the top minus the top times the derivative of the bottom all over that bottom function squared. To clean this one up, we're once again going to have to clear the fraction. So we have another double fraction type of deal happening. So I'm going to multiply both the top and bottom by x to get rid of that 1 over x, which was the derivative of ln x. So when we multiply that in, we end up getting an extra x in the second piece, but getting rid of the 1 over x in the first piece on top there, and we'll have an x there on the bottom as well. Now I'm just going to factor out a secant x on the top of the function, and then I'll be able to cancel with the secant squared x on the bottom. And that's my final answer for that one there. So next we're going to discuss higher order derivatives. So here I can do the third derivative just by taking three derivatives in a row. So I'm going to take the derivative of that original function. That's my first derivative. I go ahead and take a derivative again. That'll be the second derivative. And if I take the derivative of the second derivative, I'll have the third derivative. So with a trig function like this, it's a lot more simple. It ends up just oscillating back and forth between sine and cosine, and we do actually have formulas for these as well for generic higher order derivatives of trig functions if you want to check that out. All right, so that's it for our derivative practice problems. If you prefer this type of voiceover content, please let me know in the comments. And next time we'll go ahead and discuss chain rules. So be sure to stay tuned for that one.